Okay, so we are into the last portion of the module here. I want to finish up talking about sort of the flip side of dispersal, and which is sort of if you have a barrier, like what are the things that can prevent dispersal or limit dispersal or funnel dispersal into certain routes, things like that. So let's talk about barriers a little bit. And um, the effectiveness of a barrier depends on both the physical and biotic challenges that it poses to the organisms there and the biological characteristics of the organisms attempting to cross it. So there's physical characteristics of a barrier, there's biotic challenges, so it could be, the competition is higher, but the temperature could be different, or precipitation could be different, or topography, or whatever. But there's also biological characteristics of the organism, like how well the organism can adapt. Can it withstand different types of environments for very long or not? So there's all sorts of these characteristics that are going to influence whether something is a barrier to a certain species or isn't a barrier as far as preventing that species from moving around. One of those things is variation in the environmental conditions can influence the effectiveness of a barrier. So in general, barriers tend to be less effective in areas that um, have a lot of variation. And when we say effective, we're not really indicating that a barrier is a good or bad thing. Just how much of a barrier is it? Um, Realize I spelled that wrong there. How much of a barrier is it to a species that's trying to cross it is what we're getting at with effectiveness there. And so if we look at two examples of mountain ranges in Colorado, one in Costa Rica. Costa Rica is in a tropical latitude, and Colorado is more of a temperate environment. There's a lot more variation in Colorado than there is in Costa Rica. Costa Rica is pretty much high temperatures and high precipitations most of the time. And so if we were to look at the temperature differences, sort of what we have going on here is you have the temperature range, um, sort of the mean and probably the standard deviation shaded here for a mountain, and then, or sorry, for a mountain down here, and then if you're at ground level down here, and it's over the time of year. So this is like each month, what's the average temperature, and then what's the sort of variation in temperature. What you're getting at here is that, so if you're up high in elevation, which is kind of counterintuitive because this one's underneath this one, but this is the higher elevation down here. So if you're up in the mountain, there's very little overlap in the types of temperature you're getting at any point in the year. Basically, it's always going to be much warmer at the ground than it is at higher elevation. If we look at Colorado, that's not necessarily the case. Whereas if you like there are differences. Temperatures tend to be lower at higher elevation, but there's overlap, and you see these types of patterns where you're getting similar types of temperatures even at um, different elevations. So it's not going to be as much of a barrier for an organism to cross the mountains here because the conditions are at least somewhat similar during some types of the year, and you see similar sorts of patterns, and so it's going to be less of a barrier than in Costa Rica, where if you're an organism that exists down here, you're going to encounter a very different environment if you're going up here, and something that you would never encounter otherwise, and so that's probably going to be more of a barrier. So the variation in those environments and whether how different of an environment is the barrier compared to the other locations is going to influence how much of it a barrier actually is. Physiological barriers can prevent dispersal even in good dispersers. So even if you're like this puffin species is very widespread at Arctic latitudes, basically across the entire globe, but the tropics just represents a type of environment that is not conducive to this species, and so it can't cross, even though theoretically if you can span this range, then there's no real reason you couldn't go this direction too if the tropics didn't represent some sort of barrier, and you can see pretty clearly. I think that's probably the 30-degree latitude line. it just doesn't go past it. And so that's just it just can't get past that type of warm environment is not conducive to the species, and so it just doesn't traverse that. So even though it's a good disperser, you can still have environmental barriers. Barriers can also can also vary temporally or seasonally. So here in the Thousand Island region, it's a northern. This is the St. Lawrence River in a colder environment. I mean, not Arctic, but still cold enough that this freezes over winter, and so you would have ice. And obviously, ice. Mammals can walk across the ice, and we see different types of mammals that use that all the time, but that's only available during certain times of the year. If this is not frozen, then certain organisms are not going to be able to cross this. Particularly, I would say most of these are probably not going to be able to swim across these areas, and so these areas are only available to them during certain times of the year. So there's temporal dynamics there. Okay, and the last thing I want to talk about is, so if we have barriers, sometimes there's routes and corridors and things that organisms can use to get through that barrier, and those have all sorts of interesting dynamics too. And there's three sort of general categories that we think about here. So there's corridors, which are basically just a route between one habitat and another one, and it's similar enough in both habitats that it's not really preventing organisms from moving between them. So it's basically just a route that they take to get there through some barrier. A filter, on the other hand, is sort of exactly what it sounds like. Like it could be a route like this between two areas, but it's going to be different in some way between these two habitats that's going to prevent some organisms from getting through here and not prevent others. So basically, some organisms will get filtered out and will not be able to disperse, and other organisms will be able to. And that just depends on the type of filter and the type of organisms and etc. And then there's sweepstakes, which are sort of like one-time events that are so rare, sort of our long-term dispersal events or long-distance dispersal events that are so rare that very few organisms can take place in this sort of thing. So it's a sort of lottery type event. And so filters, just to show an example of this, you usually get these sort of gradients where if we're looking at these, here we're looking at the Krakatau Islands and some more in sort of the Pacific Indonesian area or Australian and South Asian island chain here. You get this gradient where if you're close to Southeast Asia, the closer you are to Southeast Asia, you get more Southeast Asian species. And as you move closer to Australia, you get a shift to Australian type species. So you can sort of see that in the light green here, you get these types of species. It's sort of decreasing, and you're getting a transition into the Australian species. So this one's going down, and these ones are going up as you move, and so you get this gradient. And so basically, this is a filter. It filters out some species from being able to move this way and this way across, and so you get this transition from what are the dominant types of species. Over here it'll be Southeast Asian species, and over here it's going to be Australian New Guinea species. So that's pretty common when you have a filter of some kind. Sweepstakes routes are exceptionally rare events. Like I said, they're events where either either they're rare or they're events where many individuals attempt it and only a few are successful. So it could be a bunch of organisms set out to find an island or something. They fly out there and only a few of them end up making it. Or it could be something even more kind of crazy. So there was in the early 1990s, there were two hurricanes, Hurricane Marilyn and Hurricane Lewis, that hit within like a week or 2 week period, had basically very similar storm tracks, and they ended up actually distributing a lot of these iguanas. I think there was like, I'm trying to remember what it was because this was actually documented. But there was like a huge floating pile of debris from islands, from like these collections of islands, and some of these got trapped onto this floating thing of debris that got pushed through these island chains by the hurricanes, and distributed the species to areas that it wouldn't have been able to get to otherwise. So that's sort of a unique sort of event, and so that might fall under the sweepstake routes there. But if we were sort of to put all this together, we kind of covered the fact that most species and individuals have intermediate levels of dispersal capacity. So that's sort of what we're seeing here, where if you're looking at the number of individuals or the number of species capable of dispersing a certain distance, most individuals and most species have an intermediate level, and that's because that's what natural selection tends to favor, is some intermediate level. So most individuals fall right in here, but the immigration rate differs by the mode of dispersal. And so in general, as you get away from the source location, the immigration rate tends to decrease. So you're going to get fewer individuals showing up as you get further away, but it's going to matter what type of dispersal they're using. So if you're using passive dispersal, that tends to decrease pretty consistently right away. If you move away from the source, you get a right away decrease in immigration rate. But if you have active dispersal, it sort of takes a little while. Like if you're somewhere in here, most organisms can still get there. They can increase their energy expenditure a little bit and push a little bit harder, and can still get to that distance. But once you get to a certain level, then it starts to drop off pretty quickly. And so somewhere in here, you're only getting like maybe the most fit individuals are able to actually disperse that distance away. And then once you get to a certain level, nothing can really do it. And so we're able to abstract these sort of models that indicate how different types of dispersal can influence the immigration rate. Okay, so I want to finish up here. Again, 3 sort of main points that you could take away. Dispersal, for one, is a fundamental process influencing biogeographic patterns. Long distance dispersal is both rare but very important on long-term scales, and dispersal capacity depends on both the organism and the environment. Okay, and there's one more reading, so keep working your way through here. Finish the module, and then there's a quiz on this module instead of a assignment. So there's a quiz, so be aware of that. You can have your notes out and whatever, obviously. So just keep working your way through there, and I will see you next week in the next module.